Okay, so linear equations, system of linear equations in three variables, or you can say system of three linear equations in three variables. The linear equation in three variables x, y, z is can be written in the form of ax plus by plus cz is equal to d, or 3x minus 2y plus z is equal to 7 is one of the example of, of an equation with three variables. Any ordered triple x, y, z that makes the equation a true numerical statement is said to be a solution of the equation. For example, the ordered triple 2, 1, 3 is a solution because it satisfies the given equation 3x minus 2y plus z is equal to 7. So if we substitute this value in left hand side of the equation, 3 into 2 minus 2 into 1 plus 3, so this will be equal to right hand side, which is 7. However, the ordered triple 5, 2, 4 is not a solution because for these values cannot satisfy the left hand side of the equation. Why? Because 3 into 5 minus 2 into 2 plus 4 is not equal to 7, but is equal to 15 plus 4, 19, and 19 minus 4 equal to 15. Okay, so there are infinitely many solutions in the solution set. So it means an equation with three variables can have infinitely many solutions. That is also possible that an equation of three variables can have infinitely many solutions. Okay, so what is the remark? Main points to be noted. So what is the point to be noted is that the idea of a linear equation is generalized to include equations of more than two variables. Idea of a linear equation is generalized to include equations of more than two variables. Thus, an equation such as 5x minus 2y plus 9z is equal to 8 is called a linear equation in three variables. The equation 5x minus 7y plus 2z minus 11w is equal to 1 is called a linear equation in four variables, and so on. So to solve a system of three linear equations in three variables, such as 3x minus y plus 2z equal to 13, 4x plus 2y plus 5z is equal to 30, 5x minus 3y minus z equal to 3, means to find all of the ordered triples that satisfy all three equations. In other words, the solution set of the system is the intersection of the solution sets of all three equations in the system. The graph of a linear equation in three variables is a plane, not a line. In fact, graphing equations in three variables requires the use of a three-dimensional coordinate system. Thus, using a graphing approach to solve systems of three linear equations in three variables is not at all practical. However, a simple graphical analysis does provide us with some indications of what we can expect as we begin solving such systems. So here is again, it is revised that graphical method is not appropriate to find a system of equation with many equations that more than one and two or three equation. So, but graphical system is good to solve a system of equation with only two equation. In general, because each linear equation in three variables produces a plane. A system of three such equations produces three planes. There are various ways in which three planes can be related. For example, they may be mutually parallel, or two of the planes may be parallel, with the third intersecting the other two. You may want to analyze all of the other possibilities for the three planes. However, for our purposes at this time, we need to realize that from a solution set viewpoint, a system of three linear equations in three variables produces one of the following possibilities. So this is the point to be remembered, that a system of three linear equations in three variables produces one of the following possibilities. Number one, there is one ordered triple that satisfies all three equations. The three planes have a common point of intersection as indicated in figure 14.4. So this is the figure actually where the three planes have a common a point of intersection. So there is one ordered triple that satisfies all three equations. The three planes have a common point of intersection. So one plane is this upper side, the other plane is this yellowish side, and the third plane is this bluish side. So these three sides actually is representing three planes. And these three planes are intersecting at a single point which is marked with a black color. Okay, so there are infinitely many ordered triples in the solution set, all of which are coordinates of points on a line common to the three planes. This can happen if the three planes have a common line of intersection, as in figure 15, 11.5a, or if two of the planes coincide and the third plane intersects them, as in figure 11.5. So here is actually you are seeing only two planes in figure B, because these two planes are coincide with each other. It means they are above each other. So here you are watching only two planes because one plane is coinciding with other. And in this figure, there are infinitely many ordered triples in the solution set, all of which are coordinates of points on a line common to the three planes. Okay, so if the three planes are in this way, so this there is a common line. So this is a common line, and on this line there can be many solutions. So that is why we have that we say that in this situation we have infinitely many solutions. Third possibility is that there are infinitely many ordered triples in the solution set, all of which are coordinates of points on a plane. This can happen if the three planes coincide as illustrated in figure 11.6. So there is another possibility. There are infinitely many ordered triples when three planes coincide with each other. And the fourth possibility is the solution set is empty. Okay, thus we write with phi. This can happen in various ways as illustrated in figure 14.7. Note that in each situation there are no points common to all 3 points. So because these in figure A, three parallel planes, so they cannot intersect each other. So that is why the solution is empty. And in here, two planes are parallel. So two planes coincide, and the third one is parallel to the coinciding plane. So also in this situation, the solution set is empty. And in this situation C, so because these three planes are not intersecting at one point, like two planes are parallel and the third intersects them in parallel lines. So that is why there is no common point between the three planes. And also this is the situation. So no two planes are parallel, but two of them intersects in a line that is parallel to the third plane. So these are four situations where there is no solution. Okay. So now that we know what possibilities exist, let's consider finding the solution sets. For some systems, our approach will be the elimination by addition method, in which systems are replaced with equivalent systems until a system is obtained that allows us to easily determine the solution set. The details of this approach will become apparent as we work a few examples. So let's consider the first example is that solve the system. So this system have three linear equations in three variables. So first equation is a linear equation in three variables. Second equation is a linear equation in two variables. And third equation is a linear equation in one variable. Okay, the form of this system makes it easy to solve. From equation 3, we obtain z is equal to 4. So that is the first clue to solve the system of equation, because this third equation have only one variable. So that is why it is easy to find the value of z, which is equal to 4. So then substituting 4 for z in equation 2, we get, so z is equal to 4. We can put z 4 and we will have 5y is equal to minus 15 and y is equal to minus 3. So that is why now we have two values, that is z equal to 4 and y is equal to minus 3. And then finally substituting 4 for z and minus 3 for y in equation 1 yields. So these two values, value of y and value of z, if we substitute in the first equation, we have a value of x which is 1. So it means we have a solution set which is 1, minus 3 and 4. So this solution is a single solution, and this can solve the system of equations. So if we substitute this value 1, minus 3 and 4, so easily the left hand side is equal to right hand side. So okay, the next example is uh, solve the system x minus 2 y plus 3 z is equal to 22, 2x minus 3y minus z equal to 5, 3x plus y minus 5z is equal to minus 32. What is the solution? So again, so now the problem is that the three equations have three variables. So we cannot uh, directly can have a value of any variable. So equation 5 can be replaced with the equation formed by multiplying equation 4 by minus 2, okay, and adding this result to equation 5. Okay. Equation 6 can be replaced with the equation formed by multiplying equation 4 by minus 3 and adding this result to equation 6. The following equivalent system is produced, in which equation 8 and 9 contain only the two variables y and z. So what he has done, actually multiply equation 4 with minus 2. So if we multiply equation 4 with minus 2, so what will happen? The first, this fourth equation will be changed, minus 2x plus 4y, okay, and minus 6z is equal to minus 44. And then we can add in this equation 6, equation 5, so we will have a different values. Y minus 7z is equal to minus 3. So that is why So first what we have done, we multiply equation 4 with minus 2, and then we added this equation in equation 5. Okay, and similarly equation 6 can be replaced with the form multiplication 4. So again we have multiplied equation 4 with minus 3 and add this equation to 6. Okay, so we have performed two steps. First step is we have multiplied equation 4 with minus 2 and we have added to equation 5. And then we have multiplied equation 4 with minus 3 and added into equation 6. So there we have gotten this system. And the first is the same because we have used this first equation to reduce the second and third equation in a simplified form. So there should not be change in equation first. This second is changed because we have multiplied equation first with minus 2 and added in equation 2. So then we have y minus 7 is equal this one. And the third one is we multiplied equation first with minus 3 and added in equation 3. So 7y minus 14z is equal to minus 98. Equation 9 can be replaced with the equation formed by multiplying equation 8 by minus 7. So equation 9 can be replaced with the equation found multiplying equation 8 by minus 7. So if we multiply equation 8 with minus 7 and we add in 9, we will this y, we can eliminate y and we will have finally 35z equal to 175, and from here we can have a value of z which is equal to 5. Okay, z is equal to 5. Then substituting 5 for z in equation 11, we obtain this y minus 7 into 5 equal minus 39, and we have y is equal to minus 4. So finally, substituting minus 4 for y and 5 for z in equation 10 produces value of x, that is x minus 2 into minus 4 plus 3 into 5 equal 22, x plus 8 plus 15 equal 22, x plus 23 equal 22, and x is equal to 22 minus 23 equal to minus 1. So then we have this system of a solution of this system minus 1, minus 4, and 5. Okay, so next example is again the example of three equations. So 3x minus y plus 2z is equal to 13. So 5y minus 3y minus z equal to 4. 4z plus 2y plus 5z is equal to 30. Here what we can do, we can multiply this first equation with 4. We will have here 12. And then we can multiply the last with 3. So here again we have a 12. So then these two equations can be subtracted. Or we can say that we can multiply first equation with minus 4 and then we add this first equation in the last one and you will eliminate the value of x. Or you can also eliminate value of y if you multiply first equation with 2 and you will have here 2y and you add in this last one, this y will be eliminated. Okay, so in the same way you can do operation with the second line, that if you multiply the first equation with 5 you will have here 15, and then you can multiply the second equation with 3 and you will have here 15 again, and you can subtract these two equations and x will be eliminated. Okay, so this is another way. So equation 14 can be replaced with the equation found by multiplying equation 13 by minus 3. So multiply first by minus 3 and add this result to equation 14. Because if you multiply this uh, with minus 3, you will have here minus 9. Okay, here you will have minus 9, and here you will have plus 3y. Here you will have minus 6z, and here minus 39. So if you see, the values of y will become equal because plus 3y minus 3y. Okay, so you can equate any variable. So here in this operation, uh, these coefficients of y are equal after multiplying with minus 3, equation 1. So equation 14 can be replaced by multiplying equation 13. So if we multiply equation 13 with minus 3, so values of this coefficients of y becomes equal, okay, of equation 13 and 14. So adding in 14, so y will be eliminated, okay, and we will have, what we will have, you see, there is no y in second equation, so because y is eliminated, okay. And then what's the next operation is that equation 15 can be replaced with by multiplying 13 by 2. So if we multiply 13 with 2, again coefficient of y becomes equal to the coefficient of y in last equation. And again here y will be eliminated and we will have this third equation without y. Okay, so that is the way actually. Now if we multiply equation 17 by 5, so if we multiply 17 by 5 and equation 18 by 2, we get the following equations. So 17, we can multiply 17 by 5. So this is 17. By multiplying with 5, we have there minus 24x, and here minus 35z, and then here 5, 6 are 30, and 5, 3 is 15, plus 3, 18. So we will have this equation. So minus 20 minus 35 minus 180 degree, 180. And if we multiply 18 with 2, we have 20x plus 18 plus 120. And now just look at the value of x. These becomes equal. So just add these two and x will be vanished. And you will have this. Adding these two equations, you have this minus 17z equal to minus 68. And ultimately now you have the value of z equal to 4. And this value you can substitute in equation second. So and here you will get this value of x, which is equal to 2. And after having this value of z and x, we can substitute these two values in first equation because the first equation has all values, all three variables. So substituting these in first, you will have this y is equal to 1, which is 2, 1, and 4. So this is the solution. So next example, again it has three equations. So we can see what will happen. So here we can eliminate z. If we multiply first equation with 2 and add in the second, you will eliminate this z. So you see, so there is no z in the second equation. And similarly, if you multiply first equation with 3 or minus 3 and then add in the last one, so you will eliminate z. So you will have equation minus x minus 2y. And after this, you don't need to multiply even. So add these two, you will eliminate y. So this is again easy to do this. Okay, so you see it has the same suggestion that equation 30 can be replaced with the equation formed by adding equation 29 to equation 30, and here y is eliminated. So then you have this x is equal to minus 2, okay, and this minus x, value of x can be substituted in equation 2, and you have y is equal 6. So this minus 2 and 6 can be substituted in first equation, and you will get this z is equal to 0. So in this way, we have this solution of this equation minus 2, 6 and 0.